Welcome to the solution concentration video tutorial. This is an introduction to an overview of the solution concentrations that are commonly used by allied health students in Chem 309 and 305, 306. So let's start with what the definition is. A solution concentration is a quantitative measure of the amount of solute dissolved in a given quantity of solution. So there are a ton of different types of concentration units out there, and so as I mentioned in the introduction, we're going to focus on the four main types that allied health students will encounter. The first type is very straightforward. It's the mass of the solute over the volume of solution. So this will be mass of solute over volume of solution. Okay. Now, mass is the most correct term, mass over volume. But don't be surprised if you see weight over volume. They mean the same thing, and it just depends on who's writing it. The second common solution concentration is percent mass over volume. And so it will always be the grams of the solute, and this will be defined as over the milliliters of the solution. So it looks very similar, right, to the one above. But here, the mass and the volume, there's no rules. This can be any mass unit and any volume unit. But when we see percent mass volume, it's always going to be the solute in grams and the solution in milliliters. And then we need to acknowledge this percent here. So the percent is very literal. The percent, right? So percent means per 100, right? There's 100 cents in a dollar, 100 years in a century. So the difference between mass over volume and percent mass over volume is that it's grams of solute over 100 milliliters of solution. So that allows for the percent part. And once again, often this has the parentheses here, percent mass over volume, or depending on who's writing the concentration, they may use W for weight. So you just want to recognize this as being interchangeable. Then we have the concentration of moles over volume. And here we're going to use molarity. And so molarity is represented by an uppercase M. So anytime we see an uppercase M, that tells us moles of solute per 1 liter of solution. So this concentration unit is similar to percent mass over volume in that we have specific units for measuring the solute and then a predetermined volume for the solution. And so it's really important that every time you see an uppercase M, you translate it into moles of solute per liter of solution. And then the fourth type of concentration unit that's common in allied health and biological contexts is equivalence per volume. And so equivalence is usually an uppercase EQ for equivalence. And then it could be any volume, but we'll just go with liters of solution. Okay, and so what is special about equivalence is equivalence have to do, so what's the deal with equivalence? It tells us about the amount of charge present. right, in the solution. Okay, so equivalence is only going to be used with ionic compounds. So it makes no sense to use equivalence when we're talking about covalent compounds because covalent compounds are neutral. So equivalence is a special type of solution concentration when we're concerned about the overall charge of the solution. So here is an overview of the different concentration units that I've just described. So here we have the percent mass volume or weight volume. So there's the definition. And so if we look at the plasma concentration of sodium chloride, if we use the concentration units of percent weight volume, we would describe that concentration as 0.60% weight volume or mass volume. So it's the same solution, but if we change the concentration units, so this would just, right, here's milligrams and deciliters. So this is an example of mass over volume. Here, it's the same sodium chloride in the same solution, but if we change the concentration units, now we describe it as 600 milligrams per deciliter. For molarity, right, that's the uppercase M, which is moles of solute per liter of solution. That same sodium chloride concentration, if we describe it in terms of molarity, would be 0.103 molar. And because this is an ionic compound, we could do it in terms of equivalence. And equivalence, we can use the metric prefixes like milli. So here's milli equivalents per liter, which is common with biological solutions because the concentration levels are very low. And so here, when we're looking at sodium chloride, we recognize that it dissociates into one sodium ion and one chloride ion. So the sodium ions would create 103 milliequivalents of charge, and the chloride ions would contribute 103 milliequivalents per liter of charge. Now, here we had an ionic compound. If we go to urea, urea has the form, here's the chemical structure for urea, and urea is all nonmetals, it's a covalent compound. So we can describe the concentration of urea in our blood plasma using the percent weight over volume, or mass over volume, or molarity. However, we're not going to talk about milliequivalents because there's no charge present. And the thing I want to make sure that's really clear here is these concentrations look very different, but they're describing the same solution. So that's why it's important for you to become very comfortable with these concentration units so that you can convert between one or another and recognize that they're still, even though they look very different, they're describing the same solute concentration in the same solvent. So this concludes our introduction to solution concentrations, and now there will be subsequent tutorials that will focus on each one of these 4 concentrations. So if you need additional practice doing calculations with any one of these 4 different types of solution concentrations, please refer to the additional video tutorials.